Hi, Dave Beasley here. I'd like to welcome you to a live coding project. I'm going to try to work through the Ray Tracing in One Weekend project by Peter Shirley. And we're going to code this in Rust. I think this is a fun project to do. It was one of the first projects that I attempted when I was learning Rust. The reason I like it is that Rust is often compared to C++. And so a lot of what we're going to do in here is look at C++ code, convert it to Rust, kind of talk about differences between the two. Another reason that's kind of fun with this project is you get to make a lot of pretty pictures. So at the end, you'll get to make a picture of something that looks kind of like what's showing on the screen here. I also have a personal connection to this project. Turns out that Peter Shirley, the creator of the Ray Tracing One Weekend project, was an assistant professor where I went to school at University of Utah. And I seem to recall him heckling me at my dissertation defense. So somehow I have to get back with him at that. I also learned, weirdly enough, that my kids go to the same high school where Peter Shirley went to high school. And the only reason I know about that is I'm at back to school night, and Matt Godbolt, the compiler explorer guy, comes up to me and he says, "Yeah, I just found out that Peter Shirley went to school here." So Matt and I, we went and looked at the hallway with all the famous alumni pictures. We didn't see Peter up there. Frankly, we're kind of disappointed. Anyway, enough about Peter, enough about me. As far as this project goes, I would encourage you to try and follow along if you want. If you're trying to learn Rust, try to do the same things that I'm doing, pause the recording and so forth. I'm going to be following the project more or less as written. Okay, we'll be going through the website. Some of the code will be pretty different. Not going to completely literally copy it. I am going to adapt it into some Rust idioms that I think work a little bit better. But I encourage you to follow along. URL is on the screen right now. So the very first thing that we're going to do with this project is we're going to create a new Rust project for this using Cargo. So I'm going to create a new project for this called Raytrace using Cargo. And the very first thing that I'm going to do here is just run it. I'll be using Cargo for all the running, compiling of the code in this project. So do Cargo run. It should come up and just print like a little hello world message for you there. First thing that I'm going to do is just go find that. Turns out that when you run Cargo, it creates a whole directory for you. The main program is in the source directory. You'll see main.rs. I'm going to go find that and just change it. Okay, so I just changed the message to, I don't know, hello Ray Tracer or something like that. Mainly what I'm doing here is just making sure that I'm editing the right file and that I know what I'm working with here. Okay, Cargo run comes up, hello Ray Tracing. So that's the start of the project. You want to create a new Rust project, just make sure that you're compiling okay. So with that, what we're going to do next is start working through the tutorial. One thing about the tutorial is that I'm going to be pretty much focused on the code portion of this tutorial. I assume that you can read the parts talking about computer graphics and all of the foundations and the physics and so forth. So we're gonna primarily focus on code. So the very first piece of code that comes up is there's a bit of C++ code just to emit a test image. So what I'm going to do in the first part here is essentially adapt to this main program to copy the C++ code. So mostly this is going to just look the same. Okay, so I'm going to set some variables. This first part here is printing out like a little image header. Rust has some nice printing features that are that make this a little bit nicer. I can just do that print in one line, and I can pull in variables if I want doing that. And it looks like we've got a couple of loops here. That as conversion is basically a type conversion on it. Okay, setting red, green, and blue values. And then well, it looks like we're going to do some int conversions on this thing. Honestly, that looks a little janky to me with the 255,999 part, but we're just going to roll with it here and see what happens. Again, have to do some types on it, and then we're going to print out the pieces here. Guess we don't need the trailing new line on it. I guess we don't need that up here too. Okay, so let's go ahead and start with that. See what happens with that. Try running that. Okay, we're already getting a compiler error message here. Oh, okay. So what this is, Rust is super picky about mixing numeric data types. What you've got going on here is this is a float 64. This image width -1 is an integer. Rust is just not going to allow that. If you come to Rust from some language like Python or something where it's really permissive, you're going to have to get over that. So what I need here is I need to include another type conversion of some kind. This is actually something that came new to Rust. I was actually somewhat annoyed by, actually. It was like, oh, come on, why can't you just do the math? But one of the things about Rust is it really is picky about making sure you do the right thing, and that includes mathematical calculation. I've definitely been burned in the past by math calculations going wrong. Okay, so this is what the output looks like. It's a bunch of text. Frankly, not very exciting, and so forth. What we're supposed to do with this is basically write it to a file, and then maybe try to view it in an image viewer. Okay, so technically what you could do with this is maybe do cargo run and then pipe it to an image, and then you can try to view the image in some tool or something like that. I'm using iTerm2 on the Mac here. One of the cool things about the terminal is it can actually view images in the terminal using ImageCat. Okay, so there's my test image like that. Okay, looks pretty good actually. Just to shorten that, by the way, I'm probably just going to run the code and pipe it into ImageCat. I realize that this is a feature of my terminal, so you may not be able to do this, but I'm going to take advantage of what is provided to me there. Okay, so this is essentially the hello world in Rust. Doesn't look too much different from the C++. A few little things with numeric conversions and so forth, but basically the same idea. Now, a few other things that he does here is he adds a progress indicator bar or progress indication thing. This is going to be useful a little bit later on. Turns out ray tracing is pretty computationally intensive, and as we get into later stages of the project, you might want to just know like what it's doing, as opposed to having the code just sit there for a while. So what's going on here is he's printing out the number of scan lines remaining. This is some C++ code that is routing output to standard error, different IO stream. Rust has something like that. We can do, I think it's eprint. I don't know. Let's try doing that. Oh, one thing about Rust, if you're going to do mathematical calculations in the printing, you've got to do it outside like this. Okay, so we're going to do image height -j. Okay, let's try that and see if it works here. I guess we should put the thing at the end here to print out done too. Okay. He's got a whole bunch of spaces because that carriage return character, what that does is just goes back to the beginning of the line without printing a new line on it. let's make sure that that compiles, and then let's I don't know, let's run it, pipe it to a file. Okay, so you saw it very briefly print some scan lines. It was probably almost too fast to see, but it's just going to print like a little progress indicator on it. Maybe if I pipe it to a file, let's make sure that that works too. Okay, so there's the image there. Okay, so this is just the starting point. Have a main program, have it producing an image. This main program is going to evolve as the project kind of progresses. So we'll come back here and edit this as we go. Okay, next thing we're going to do is we're going to introduce some foundations in the project to basically work with mathematical calculations. So this whole project is just filled with basically trigonometry and like three-dimensional kind of coordinates and things like that. So what is going on in the next step of the project is the introduction of data structure. So the project introduces a vec3 class, does a whole bunch of vector operations, operator overloading, a bunch of stuff. Frankly, there's a lot of kind of ceremony going on with this C++ code. So over on the right, got the C++ code. There's, vec3. We've got an array inside. We've got multiple constructors. We have accessor functions. Honestly, I look at this code and I'm like, this is way too complicated for me. Okay, what is going on with that? So so what we're going to do on the Rust side is, first of all, I'm going to make a new file called vec3rs, and the thing that we're going to put in here is essentially a struct for vec3, and I'm going to dispense with a whole bunch of that C++ ceremony. Okay, so I'm not going to do this inner vector. I'm not going to do accessor functions or anything like that. What I'm going to do is vec3 is basically three coordinates, x, y, and z. They're all floats. So we'll start with that. Another thing that I'm going to provide for this is essentially a convenience function to create this. This is often pretty standard Rust practice to do something like this. Is to write some constructor function that is essentially the constructor up here. It's just like, you give me three coordinates and I'll make a vector. If I wanted this other constructor to do zeros like that, I can do that in Rust. I don't know whether I really need to do that, but if I wanted to do that here, I would just make a different function, like 0. And then I could say vec3 new 0, 0, 0 or something. Again, I don't know whether really need that in the project, but that's what I'm going to start with for the data structure there. Let's just make a vec3. A couple of other things that are kind of nice in data structures if you're working in Rust is to put debug trait on this. This is essentially going to allow printing. If you wanted to see this thing really nicely, so that's useful for sort of debugging things if you want to have that. And we may add some other things to that later on, but let's just start with this. Okay, so we're gonna make a data structure for vectors. To add this to the project, I need to come up here and just include a mod declaration in the main program. What I'm doing here is I'm listing modules that are part of the project. If I don't include them there, then Rust isn't going to find them when I compile things. Okay, so essentially anything I want to use need to include mod there. Let's just make sure that this compile. Do a cargo build. Oh, 0. Okay. Oh yeah. Okay. This is a pretty frequent mistake that I make. Though the last kind of operation or last expression in any kind of function is what gets returned, but it's very common to put a semicolon on the end by accident. So that's what it's complaining about. If you put a semicolon on the end, then it doesn't end up returning that value. Instead, what it returns back is essentially the Rust unit type. Looks a little weird, but if you come from Python, it's kind of like none. Okay, so I just had an extra semicolon on there. Okay, so that's good. Basically compiled. Actually, there was sort of two things that happened there. Just first of all, it makes sure that this file is being included in compilation, which the mod did. And the fact that I had an error in it was probably for the better, because then I could actually see that it was compiling. Okay, so we're gonna start with that. Another thing that happens in the project is the project uses both vectors and points, and often kind of mixes operations with those and so forth. One of the things that we see here is a type alias, and I'm going to do something like that here as well. I'm essentially just going to declare point3 to be the same as vec3. It'll let me kind of reuse some of the code between the two, so I'm gonna use that. Some of the other C++ code in here, we'll come back to that. This may be a little bit of a departure, but there's actually quite a bit of code to digest in this C++ code to start, and dealing with all the kind of the mathematical operations on vectors and so forth. I think what I'm going to do is I'm going to implement that as it is actually needed in the project. So I'm gonna kind of resist the temptation to code things that are not needed. And right now, the code does not need any of this. Okay, right now it just produces that test image. So for now, we're gonna add the vec3 to our project and work with that. Another thing that is happening here is the introduction of a file related to colors. Okay, so we're just working with data structures basically. So this is going to be another file, color.rs, where we are essentially defining, sort of a color data structure and a function for writing colors and so forth. One of the things that is going on here is that the project is essentially making kind of like sort of a type alias to vec3. I'm actually not going to do that. I feel like colors and vectors in some sense are basically two different concepts. And so I'm going to take kind of a lead from Rust. Rust doesn't let you mix integers and floats like in math calculations. You got to be really precise about that. I'm going to do the same thing here. I'm going to introduce a separate data structure for colors, just because I kind of feel like it's I feel like it's a different concept. So this might look a little bit, maybe a little bit redundant with vectors, but I have my reasons for doing it. It turns out that that a lot of the operations on colors are different than the operations on vectors, and I would I'd just be happier just kind of keeping them separate. Okay, so we're going to introduce a struct for vector here. We'll give it a new this kind of write color thing is going to be used to write a color out to a file. Well, this is kind of interesting. Let me put a question mark in there. Okay, so we're gonna write a pixel color out. Oh, this is gonna be. Okay, so we're doing a little calculation here. One of the things that I'm kind of stuck with here is what to put on the output here. This is essentially specifying a like a C++ interface or a C++ abstract class. Basically saying, okay, there's some output stream here. I may not know what that is in Rust just to start with. So let me take that away for a second. And we'll come back to that. So what I'm going to do for the moment here is like, let's just change this into like a print. Okay, so we'll try to fix that. But what I'm going to do here is basically we're gonna change the right color to we'll just print to kind of the standard output. We're gonna ignore this out O stream thing like that. And then what we're gonna do is essentially modify the main program to use this color thing. Okay, so let's go back to main here. First of all, if we add a new file, we've got to include a mod in here. And what we're going to do here is wow, it looks like we're making, okay, so we're going to create like a pixel color. Okay, it looks like we're going to do this all at once here. Okay, so we're going to create a pixel color like that, and then what we're going to do is write the color out to the screen. So we're doing a little bit of kind of cleanup around I/O. Okay, let's try that. Rust is suggesting that I okay, I have to basically include this thing correctly here. Okay, it's not finding color or right color. One of the ways that I can fix that is I could just follow the suggestion that it offers. I could say create color, right color, and then I could say create color like that. That will probably work, and hopefully it will work. Let's see. Okay, I got it all. R-byte. Oh, I'm not even okay. I mean, what am I doing here? Let. I've like switched into C++ mode or something like that. Okay, let. Okay. Dave needs more coffee. Okay. So there's that. I also have like a little typo there. Okay. Okay, so that builds. That should let's see if it still can generate an image properly. Okay, still making an image. Few little typos there. I'm just waiting to switch into Python mode in a second here. Okay, so as far as like fixing the names, you could do this. This is frankly a little bit verbose for my taste. If you wanted to shorten that, one of the things that you could do is you could come up here and just say use color star or something like that. That will let you use those names without all the ceremony in front of it there. Okay, so that we'll use that. One thing about this is that the use is pretty different than the mod. I just want to emphasize that this mod thing is basically declaring that file is part of the project. The use is actually more about just namespaces. it's bringing the names and color just kind of local so I can use them. So they're kind of two different things going on there. Okay, so this is kind of where we're at the moment is that kind of writing output. Now I do want to return to this the fact that this thing had was supplying an output stream on there. And basically, like we had the C++ stand O stream thing. If you know about C++, this O stream is essentially some kind of abstract class. It's like an interface abstract class. What happens is the different I/O streams inherit from that, and then you're basically working with inheritance in C++. Rust does not really have that. Well, actually, it does not have that. It does not have inheritance, actually. But what Rust does have is this this notion of traits. Okay, there's this trait system, and essentially what we can do here is if we wanted to emulate that, I could come in here and I could say, well, out needs to implement some kind of write trait. Okay, so what you're going to do is you're going to give me something that I can write to. And I'm pretty sure that there's like a write line macro or something where I can say, okay, I want to write to out. Okay, so this is what I would do in Rust is something like this. I would say, okay, you're going to give me something that I can write to, and then I will write to it, and this impl write is going to be generic. It's going to, anything that knows how to write to to a file or something should work with that. Now, I'm pretty sure that this is probably not going to compile right away. It's very easy to forget like some detail when you try something like this. Okay, so what's happening here is it is complaining that is not in scope, and then it's offering a few alternatives. I mean, since we're performing I/O, it is probably this standard I/O write that it wants. So what I'm going to do is let's include that. Kind of follow the suggestion of the compiler. Okay, it is okay. A few other suggestions. It is complaining that the out that I am providing is not mutable. Okay, that is fixable. Okay, so let's make that mutable. Kind of makes sense that would be mutable. I mean, when you're writing to something and you're having some kind of side effect, mutating that. Okay, now it's complaining that I am not providing the argument to that. Okay, so okay, that makes sense. Let's go back to main here. What it wants me to do is provide an out. Okay, so I need to have like some kind of out, and I'm pretty sure that I can get the out by, I think that's probably in like standard I/O, maybe standard out or something like that. I think we can get a reference to that. Okay, so let's try that. Okay. Getting kind of an interesting error message here. Use of moved value out. What is going on here? So what is going on here is maybe one facet of Rust that is maybe one of the most important things to kind of grapple with as you learn the language. Let me do a little example of something. Okay, so I'm just going to go off into a separate file for a second here. So let's say you made a data structure. I'm just going to make it so I can print it here. Okay, so let's say you had some struct in here, and let's say you had like some field data like that. And I'm going to, I'm just going to make one of these. Okay, so let's say you make an A like that, and then I'm going to print it out. This is a good example because we can experiment with printing and so forth. Okay, so this is not a very interesting program, but it's got a struct, has some data, creating it, I'm printing it. Let's see if I can compile that first of all. Actually, I'm just going to do this with the Rust C here. Okay. So compile example.rs. Okay, it's complaining about X not being used. That's fine, and we'll and then we'll run it. Okay, so you see something like this. X is 23. Things get really interesting if you start passing data around to functions. Okay, so let's define a function here that, like print A. And I'm going to have you give me an A, and what I'm going to do is I'm going to move the print line in there. Okay, so the print line is going to go in there, and I'm going to do this. Okay, so I've moved this to a function. Let's compile it. Make sure that it works. Actually, I'm going to put like a different statement in here just so you can actually see that it's calling different code. Okay, A is A. Okay, let's run that. Okay, so we see that is working. The thing that is a little strange though is that when this operation took place, what happened is this variable basically got moved into the print A function. So what happened is this kind of moved there, and in fact it is gone afterwards. So if I wanted to do something like I don't know, like print A afterwards, like let's say I wanted to do something like this after the fact, it turns out that will no longer compile. You'll get an error message. Well, first of all, I'm not using the print line macro, so let me fix that for a second. But you'll get some error message from Rust, and it will complain about maybe cloning or some other thing. Okay, this is the borrow checker coming into play. It's basically saying you're using a moved value. So I'm faced with sort of two choices on this thing. It's okay. So the value is basically gone. Okay, so it's like when you do that, the value has gone away. One of the things that I could do is put I could clone it. I could do this. Okay, so this is gonna, this is basically gonna give print A copy. So I could try doing that. In order for that to work, the clone method has to be available, and it turns out that that's not something that Rust provides by default. I have to add it, so I have to basically say I want clone on there. So that is one way to deal with that problem, is to basically clone it. I'm gonna fix my print real quick. This is actually a very common thing that Rust programmers will do, is go through their code and put clone on things to fix problems like that. The other thing that you could do, okay, so if you didn't want to clone it, like let's say you're opposed to cloning, would be to pass a borrow instead. Okay, so I'm going to put like an ampersand on there. And then what I would do instead is when I do the print A, I would use ampersand on it. So print A, ampersand A, like that. So that's another way to fix that. Let's see if that works. Okay, so it's happy with that. and now it is working. So having seen that, let's come back to main for a second and just study what is actually going on here. Okay, so what is happening with this is this file. Okay, the standard out here. This thing. I'm basically getting like a variable that refers to the standard output stream. And then what is happening with right color is that I am basically giving it away. I'm giving it to right color, and then it's gone. It's like it no longer exists on that. Okay, so question is, what do I do about that? I mean, if I go back to my, if I think about my example, one possibility is that I could put clone on it. That feels a little weird to me. I'm not even sure that that's actually going to work because files are sort of strange, right? It's like, okay, I'm going to do a clone on the I've actually never tried that in Rust. I don't even know if that's going to compile, to be honest. We can try it, but nah. Okay, I'm not surprised that doesn't compile. I mean, that seemed real shaky to begin with to even do something like that. So and it comes back, says, yeah, I can't do that. So the only other option would be, maybe pass a borrow to it, do right color out. I'm going to have to come in and change the color to indicate that we're going to be passing in, a borrow to something that implements right. Another thing that is a little tricky with this, well, we'll compile it and see what happens, is writing does require mutability. So in order to do that, I have to basically pass in like a mutable reference to something that implements right. And it still doesn't work. Rust is complaining that the types differ in mutability. It's really picky about this. So this is, in order to do that, I have to essentially say, I'm going to call right color and I'm going to pass it out, and I need to tell right color that this thing is in fact mutable. And it still doesn't work because I did not declare the variable to be mutable. It's like that mutable thing's like a virus on the code. It's like you cannot like Rust is not gonna let you. It's not gonna let you do that unless everything lines up. Okay, so that needs to be mutable. I need to pass that as mutable. It seems to compile, but I'm getting like a warning message. I'll get to that in a second, but okay, so let's just see if it runs first of all. Okay, it still runs. Thankfully it still works. But I did have that this warning message about the writing operation here. What is going on with that is that Rust is essentially complaining that I am not accounting for the fact that this could return an error. It's a little hard to think about why it might return an error in this particular project, but theoretically, I mean, there are bad things that could happen on a file, I suppose, like maybe run out of storage space or something like that. So the error message is basically about this not producing I'm not accounting for the error. Okay, so what is happening here is that there is some error that comes back, and there are essentially two different variants of this thing. This is basically, it worked. Okay, so you could have that, or let me go down here, or there's like an error case. Now, what to do in here? I mean, okay, like what am I supposed to do with this result? Or the error for this, manner. I don't even know whether I really care about the result if it worked. I mean, what would I do with that? I mean, I could just shrug it off. Okay, it worked. If it failed, then something is seriously wrong in the code. I suppose I could panic and just I don't know, print it out or something like that. Okay, so I mean, I could put this into the code to kind of account for that result. They'll make the warning message go away, but frankly, I'm kind of annoyed by the ceremony of this. What I would probably do instead of that is I would just do an unwrap call. What that's going to do is it's basically just going to assume that it works and then panic otherwise. I don't really know what I would do in this code with the panic. I mean, what am I going to do? Keep going if it can't write? But essentially, I'm going to add that Rust will be happy. It's basically happy that I'm at least accounting for the error, or at least I'm looking at the result by doing that. Okay, so the warning message goes away with that. And again, just making sure that it still works afterward. Okay, so by the end of that, what you should have a program, writes to a file, it kind of has a little abstraction around colors and pixels and so forth. We had a little bit of a mess concerning this out, and again, having to deal with Rust traits and some other things there. I think that maybe the way to kind of just understand this is that this right color is, it'll just work with literally anything that you can write to. I mean, it could be standard out, it could be a file, it could be network or something like that, but we're kind of mimicking what the C++ code was doing. It's maybe similar to what it might write in Python too. Like if I write in Python, I would just say, I don't know, just write to anything that has a write method on it, and you'll be fine. So we're kind of doing that in the Rust code here. So that is the starting point for this for the project. Basically, got 3 files. Got color, we have vect, which hasn't really been used for anything yet, and then we have this ability, this main program which produces kind of a nice little test image there. Okay, I'm going to pause for a second, and then we will return and start doing a few mathematical calculations. So I'm going to pause for a second. Okay, I'm back. What we're going to do in this next part of the project is start to include more of the mathematical calculations. Okay, so the title says that, we're going to introduce arrays, cameras, background, and so forth. One of the things about the earlier code that you might have noticed is it kind of blew off that whole vector class. I mean, there was some code for the vector that included a lot of C++, and I just sort of blew it off, and I'm like, I'll deal with that later. There's a reason for doing it later. One of the reasons for doing it later is that actually a lot of these operations aren't needed right away. So I didn't want to actually churn a lot of time fooling around with this for stuff that I don't need right now. And then the other is I want to use this to kind of explore the Rust compiler a little bit, and we'll get to that in a second. So this next portion is we're going to start filling in some details, and the very first thing that we're going to do is introduce a array class. So this whole ray tracing project is based on the idea of basically projecting light rays into a scene, and then we're going to look at what happens with the ray. Does it reflect off something? Does it hit? Does it absorb? Does it, what happens with the ray? So what's being introduced right now is we're going to introduce a ray class. And I'm going to do the same thing that I've done for the other files here. So we're going to introduce a file, ray.rs, and we're gonna put a struct in here, struct ray. And what I'm seeing in the C++ code over here is that there is a point for the origin. Okay, so we're going to have a 0.3 for the origin, and we're going to have a direction, which is going to be a vec3. Now, the class over here has got a lot of ceremony concerning, constructor functions and accessor methods. I mean, the accessor methods are basically here, and it's like, I'm not going to do that. I'm just going to make those basically normal attributes. I might make them public so that they can be accessed from outside. It occurs to me that I maybe didn't do that on the vec3 class either. So I'm going to make these... I'm going to also make those public. Just so they can be accessed. And I should probably do it for color as well. Why not? Okay, so I'll probably get like a failing grade on my encapsulation quiz for doing this. But for this project, it's all data. I don't see the need to have the accessor functions like that. We're not in Java anymore. Okay, so we're gonna make these things public like that. I see let's make a constructor on this thing. Okay, so this is following kind of the same same convention as before. We'll have a new that takes in an origin. Actually, why don't I give these things better names? Okay, so that's origin and that's direction. So origin is going to be 0.3. Direction is going to be vec3. Actually, one of the reasons for writing the new functions, by the way, well, actually, there's a variety of reasons for writing the new, but one of the reasons is that it helps the code from not being so verbose. It turns out if you don't write one of these new functions, what you would have to do is every single time you wanted to do array, you would have to write something like this. Like you'd have to use effectively like keywords. Like you'd have to say origin is like 0.3, new something, and then direction is vec3 new. And frankly, it just gets oftentimes it gets kind of verbose to do that. So the new, in some sense, it makes it maybe a little bit more concise. The other thing that's maybe a little bit more subtle, and we can maybe talk about that later, is that with the new function, you can actually do other things in here too. Like if you wanted to do something with the data, you can do that in new, and I don't know, just kind of simplify your code. Okay, so what I'm seeing in the C++ code is that there is essentially origin and direction. The other thing that I'm seeing in here is there's a function to essentially do kind of the the projection, if you will, this at operation. So what's going on here is I see this method where you give me a t, which is probably like a float. It looks like a float 64. And then what this is going to do is essentially return a 0.3. Okay, so 0.3 is going to come back. And what we're going to do is just kind of start at the origin and then add t times self-direction. Okay, so what we're doing is projecting array. Don't need the return statement as long as this is the last expression in a function. Okay, so that's what's going to come back. So I'm going to start with this. I need to add it to the project using mod. Okay, so we got to go back to the main.rs file. I always like putting a comment here so you can see what I'm editing. So this is main.rs. I'm going to put mod ray there. And let's try compiling it. Okay, it's complaining about a whole bunch of name stuff. Okay, point not found in scope. Vec3 not found in scope. Okay, bunch of naming, naming issues here. One thing that you could do is you could just fully qualify the name. You could say crate, vec3 on here. And you could say, create vec3 point3. Point3 was a type alias from earlier. Okay, so you could fully qualify it like that. That is frankly kind of annoying. I don't really want to do that. So what I want to do instead is maybe come in here and just say, okay, I want to use like point3 and vec3 out of the vec3 module. That's just bringing the names in where I can use them. Okay, so I'm gonna use the use crate for that. I want to emphasize that you don't have to include the use statement. Like if you wanted to write out the full names like crate.vec3.3, Rust will be perfectly happy with that. It's just the code is going to look really really verbose. The other thing that I want to mention, and this is maybe for the Python programmers in the room, which I am of one, you do not need to do mod, like this mod vec3 thing, like this. You don't need to do that. Sometimes Python programmers will look at this mod thing that's going on in main, and they'll say, "Oh, that's like an import. It's like an import statement. That's like, oh, I got to do mod." No. You don't need to do that. It turns out the purpose of mod is more to tell Rust that this is part of your project. It's actually more like a make file or something, where it's just like, hey, look, vec3 is part of the project, include it, and you only do that in main. I don't need to do that anywhere else. Okay, so I don't need. This is like a one time thing. I'll just say only specified here, not elsewhere. Okay, so making this thing get the names, I'm going to use crate like that. And when I build this, it's not going to work. Now this is I think one of the more interesting things about Rust, and maybe one of the most important things, is that the compiler can actually teach you how to build things. Okay, so what is going on here is that it is basically saying, I don't know how to do this add thing. Okay, so I have this is a vec3 on the left, and then it's plus, and there's this thing, and it's like, it's basically saying, I don't know how to do that. In addition to that, it's also complaining that it doesn't know how to do the multiply. Okay, it doesn't know how to do the F64 for vec3, and it says, trait mul vec3 is not implemented for F64. Okay, so it's complaining about that. It's missing traits for vec3, and so it's giving me some hints about what I need to do. It says I need to implement add. Up here, does it say that I need to implement? Yeah, it says mul vec3 is not implemented for F64. So it's teaching me about some things that I need to implement. So the way that this is going to work is I'm going to go back to this vec3 class, and I'm just going to say, okay, I'm going to implement add for vec3. Okay, so I'm going to come in here, and I'm going to say that I want to implement add for vec3. It turns out that I can also specify that I want to implement multiply for F64. Now, the multiply is a little bit tricky because it's going to want to know, like, what are you multiplying by? Okay, so I can come in here and I can say, well, I want to implement multiply vec3 for F64. Actually, it's even telling me this. The trait mul vec3 is not implemented for F64. Okay, so what I'm going to do is start with that. I am, there is a lot of information in the Rust error message there, but it's telling me that it cannot do this operation because there are these missing features. Can't do multiply, can't do add. So I'm going to add these to my vec3 code, and I'm actually not going to put anything else in there. It's not going to compile, okay, mind you, but I'm not going to put anything in there. But I'm going to do a build. And what you're going to find is that the Rust compiler is actually going to start teaching me about things that I need to add this to work. Okay, so it's actually complaining about a few names. It's saying you need to include standard ops add. So let's go up here and I'm going to do use standard ops, and then I can say, well, I need add and multiply. Okay, so what I'm going to do is bring add and multiply into scope here. And I'm going to do cargo build again. Now what it's complaining about is it's actually telling me some missing information about my implementation. Okay, so it comes in and it says implement add for vec3, and it even suggests some things that need to be added on here. Okay, so what is this thing? What is it telling me to do? Well, one of the things it's telling me to do is I need to have some specification of the output type. So what is the output type of adding two vectors together? I guess we could say it's a vector. Okay, so we need to have an output type. The other thing that it's asking me to do is it's saying you need to implement an add method. The underscore here just indicates that there needs to be some kind of argument there. Okay, so there's going to be some kind of other thing, and then the output of that, I don't know. It looks like I could maybe do self or something like that. Okay, let's just, or we could do just vec3. Okay, so it's essentially saying that I need to do add like that. Let's just do to do on it. And then it's also suggesting something like that for the multiply as well. It wants me to do like an output type. So what is the result of multiplying like a float by a vector? I think it's going to be a vector. Okay, so I'm filling in some details from the compiler. I realize that there's a lot to take in there, but the important thing is that the Rust compiler is actually teaching me what it wants. Okay, it wants to be able to add vectors. It wants to be able to multiply a vector by a float, and we'll see if it builds here. Okay, it is doing okay. So this is okay. All right. Okay, it's making progress. It's no longer complaining about the missing traits. Now it's complaining about clones. Okay, so it's complaining about that. Let's just talk about that for a second here. One of the things that we kind of mentioned earlier is that Rust wants to move things around. That's like a big default behavior in the language. And one of the things that is going on here is that this reference to the direction is actually trying to move the direction out of the data structure. This is a little bit crazy here, but what's happening is this is essentially a move operation. And Rust is extremely unhappy with that, because what is happening is you're basically going to take like this field, remove it from the structure, and then it's going to leave the structure in this kind of broken state. Rust hates that. Okay, it's like it does not like that at all. So one of the ways to fix that is to essentially clone the value. Actually, the same problem is even taking place here too. Like this is like a move as well. And so what is happening is Rust is basically trying to move the values out of the data structure, and then it's destroying the data structure, and it just freaking hates that. Okay, so one solution with the add would be to do cloning in there. Okay, we're gonna do clone like that. The only problem with that is that you can't do cloning unless you've enabled it on vec3. Okay, so just because I put clone on there, it's still not going to compile. At least I don't think it's no, it's complaining about like we don't have clone not found on vec3. So we have to basically enable that. Okay, I'm gonna have to put clone on there, and if I do that, let's see what happens here. Oh, I got the semicolon on there. Okay, I make that mistake all the time. Put the semicolon on the end of the line, and then Rust is yelling at you about that. Okay, now the thing compiles. It's got some warnings about unused code. Okay, but it compiles. But I'm actually looking at the code, and I'm like, this sucks. Actually, I mean, putting clone on there just to do that, I don't like that. In fact, I worry that what's going to happen is I'm going to make these data structures, and then I'm going to have to put cloning throughout the whole thing to like get that to work. So I very much dislike the clone. There is a way to get rid of it, which is to additionally introduce a copy trait. Okay, so what is happening here is basically clone enables kind of like the explicit clone operation, and copy enables sort of implicit copying when needed. You have to kind of opt into that, but if I put the copy trait on there, what you will find is that the those warning like all the compiler errors go away. It's like Rust is basically happy with that. I don't need it here. It's essentially Rust will look at that and say, look, I need to make a copy of it. I'm gonna do that. Just kind of implicit like that. Okay, a lot to take in with that, but for this vec3, I'm gonna enable cloning and copy. For people coming from the C++ world, if you might worry about this copy, you might look at that and say, oh, that's gonna be terrible. What's the performance of that? Or like do I really need that? I think you definitely want it. It's going to make the ergonomics of the code a whole lot better. I mean, there's a lot of there's a lot of crazy things that are going to happen if you don't have the clone and copy on there. You don't necessarily put that on every data structure, but this vec3 is kind of at the heart of everything in this ray tracing project, and I think you want it. Okay, so we're working on the ray thing now. I still have not implemented the add and multiply. Okay, so what I've got to do in here is figure out, okay, well, what does it mean to add two vectors together? And for this, we can kind of follow the C++ code. In fact, we don't really even need to look at the C++ code for this. I mean, what we're going to do for adding vectors is we're going to add components like that. And what we're going to do for the vec multiply here is we are essentially going to multiply the component. I need to do like a multiply there. Keep in mind the self here is a float, and I keep missing the star on it. Okay, so those are going to be the add and the multiply on that. This might be an opportunity to maybe think a little bit about testing too. if I wanted to write like some unit tests on this, maybe I would include some code like this at the bottom to just, I don't know, like let's write a function to maybe test the add operation. So what I'm going to do here is maybe let v be equal vec3, like new. What do we want to call it? Well, let's just do like an assert. So what we want to do here is basically just assert that these are equal to some vec that is going to have the result on it. Okay, so we can write a test to make sure that that works. You can do cargo test to run that. And what is it complaining? Oh, I know what it's complaining about. For tests, you have to include kind of the outer environment a little bit, so it knows about the name. Oh, the other thing for tests is we need to make sure that vecs can be compared. That is what this is complaining about, is that in order for that to be compared, I need to have partial equality. That's another trait that can go up here. Okay, so we'll add partial EQ on there. So let's see if that works. Okay, so you run that, and you see one test pass there. I could add another test to basically test my multiply. So what we're going to do here is maybe just test, like multiplying by a float, that this was the test here. So we're going to try multiplying by 10 and then just see what we get out of that. Okay, so those are both looking good. I did want to make one other mention about the use of the copy trait up here. This is extremely extremely subtle, okay, what is happening here. But in this code, when you have like the add method here, that self and the other essentially take ownership of the object. I had that earlier, like function example, where you have a function and basically it, like the value got moved in there. It turns out that if you take off the copy, okay, so let's say I take off the copy here. Let's say I just go back to clone. Things get really weird if you start reusing values. This is something that could happen in a test. Okay, so let's say you wanted to do a test like this, where you had a test where I just said test ops, and let's say I made like a couple of test vectors. Okay, let's say we started with something like that. Maybe I'll just copy the same test in here. Let's say I wanted to reuse the inputs. Like, let's say I wanted to do another test where I had like, okay, let's do 10.0 times v, and then do that second test. It turns out that unless you, well, let's just see what happens with that. Okay, so I'm going to try to reuse the input there. What's going to happen is actually, well, it won't even compile. First of all, it's like there's okay, that's not. I'm back to the array not compiling, but it turns out that the test won't really compile either. What is happening in the test is that it's complaining about the value v being kind of moved away. Okay, so it's like, okay, it's like V is being moved and it wants me to put a clone on it. Okay, so it suggests doing something like this, V dot clone. Plus W, and like now I'm looking at that and just saying, okay, that totally freaking sucks actually. And then I have to do the clone here as well. I mean, just basically the fact that that copy trait is missing turns the code again into some kind of horror show where I'm just having to put a lot of clones everywhere. I just really do not want to do that. And turns out if I don't implement copy, this entire ray tracing project is going to be like 50% clones probably, because there's just like tons and tons and tons of mathematical calculation. So not to belabor that point, the big reason for putting that on there is purely ergonomics. It's like trying to make the code nice to work with. Yes, it's making copies. I'm not going to worry about that right now. I want the code to be readable. I want it to match up with the project in kind of a nice way. Okay, so now the test pass, and we have that. Okay, so we've implemented 2 math operations, at least enough to get this ray thing to compile. Now, whether it works or not, well, we're gonna have to keep going here. Okay, so what is going on in the next portion of this is that some code is going to be written to basically send data into a scene. Now, there's a number of kind of hairy sort of pieces of this thing. Looks like there's a little bit of image setup being done somewhere. I don't know does it actually say where that's supposed to go? Not sure. Probably going to go in main. So let's just kind of look ahead here. Yeah. Okay. So there's a lot of kind of math kind of going, just being described here. As a computer science person, we're just going to skip the math and go straight to the code. So I'll let you read that. Essentially, what's going to happen is we're going to be projecting rays into a scene, and then seeing what they hit, and then there's this fragment of code here. So. Wow. Okay. So quite a bit of setup code on that. Maybe okay. Let's go back to main here. So it looks like what we're going to have in main is we're going to have some function called ray color that's going to take an array and return a color back. And then we have a tremendous amount of setup. This looks like a bit of typing. So I think I'm sort of debating whether I should just copy it and fix it, or whether I should silently type it. Let's just silently. Let's just type it in. Why not? While I'm typing it in, I could talk about kind of learning Rust and stuff like that. One of the things that I've found has helped me with learning Rust actually is to use very little support of the IDE, and part of the reason for that is that I'm actually trying to develop kind of a muscle memory for Rust. Having spent way too much time coding Python. It's like I want to be able to just kind of work with it all on its own, and not rely on the IDE too much. Well, this is kind of an interesting little idiom here that he's going on. He's using the ternary thing, where he's trying to truncate it make sure that it's not bigger than. Oh, he's trying to make sure that it's at least one there. Yeah, we can do that. There's going to be some things that Rust is going to complain about. I don't know whether I like that code, but we'll work with it there. Anyway, getting back to the IDE stuff. Now I've been trying to kind of get better at just working with Rust without a system. So. Again, these mathematical calculations have to have the right types on that. This division operation feels like something that I'm going to have to add to the vec3 class. Subtraction, that feels like something that's also going to have to go to the vec3 class. Let's just kind of go down the line here. Yeah, this feels like a lot. This feels like a lot of code, which is gonna. This feels like it's gonna generate a tremendous number of compiler error messages, either about type errors or missing functionality. Okay, so we're doing like a whole load of math down there, and then looks like we're modifying adding some code here. So. We have to take it on faith that Peter knows what he's doing. Now again, subtraction operation, probably going to need that to carry that out. Okay, so a lot of code got added. As noted, there's probably a lot that's going to go wrong with that, both in terms of like compiler error messages and other things. But let's just live large and see what happens here. Okay, number of things. It's complaining about names, vec3, ray, point, and so forth. Okay, so that's an easy to fix problem up here. Okay, so we're gonna include like vec3, point 3. I'm gonna include the ray struct from ray. Okay, so we're gonna pull in some names from other modules. Okay, I'm missing like a new on Ray. Let's see what else it's complaining about. Oh yeah, now here Rust is telling me about all the things that it cannot do. Doesn't know how to divide by a float. Does not know how to subtract. Telling me about the subtrait. Doesn't know. Yeah, okay. So there's doesn't know how to divide by a U size. That looks like a missing, probably a type error somewhere. Okay. So quite a few things that are kind of missing there. What we're gonna do to fix that is we're gonna go to Vec3 and we're gonna basically copy the code that we've got. I mean, okay, so implementing subtraction probably follows the same pattern as addition. Okay, so we're gonna do subtract just by copying add. Okay, so let's do that. I suspect that division. Well, let's see what it's actually complaining about for division here. It's complaining about. Yeah, okay, and there's some division. Can't divide Vec3 by float. Okay, so it's complaining that it doesn't know how to divide by float. This is a little bit different than the multiply because the float is on the other side. If you remember the multiply, it was on the left side. This is on the right side. So what we're gonna do here is that. Otherwise, it's gonna be pretty much the same. Missing that. Let's run it again, see what it's complaining about. Yeah, typo there. You're supposed to help me out on that. I don't have the live audience here. Okay, now it's complaining about div and subtract not being in scope. Let's bring those in. And here it is complaining about some type errors, and we have to think about okay, like okay, yeah, okay, a little typo there in main. That's supposed to be F64. This is probably needs to be F64 again. Rust is super picky about the mathematical operations lining up right. 64. Okay, let's kind of go with that. Okay, it's okay. Well, it looked like it. That looks like it compiles. Again, with something with that, keep in mind that Rust is trying to help me out by telling me what I need to implement. You just have to be willing to look at the compiler error message. And let's. Okay, let's keep going here. Okay, there's like a little piece here where it wants me to. Okay, so it wants me to implement. So let's just run and see what happens with what it produces now. I have a feeling it's not going to. Yeah, okay. Right now it just produces a completely black image, and I guess that shouldn't come as any great surprise, considering that we're just making a color that's all black. Actually, if we wanted to check this out, maybe I could make I don't know, let's just try 1.0 and see what happens here. Okay, now we're getting all red. Oh, okay. So right now the color function just does not do anything interesting here. Okay, so what it wants me to do now is wants me to make a unit vector. Okay, so unit direction is equal to unit vector sticks the argument. r.direction. And then it wants me to do some calculations with the unit vector. Okay. Well, that's kind of interesting. What's going on there? Okay, so don't actually need the return statement on that. Okay, so returning that. Okay, the thing that I'm seeing here is I don't think unit vector has been defined anywhere. Let's do a cargo build on that. And there's no implementation for float times color. Okay, so it's complaining about that color operation. We already kind of did that, or at least we did the multiply for vectors. So I'm going to copy that over to color here. I realize that there's like a certain duplication of code going on with this, but I still kind of stand by my conviction that color and vectors should be kind of different things. So I don't know whether I want to mix those up too much. We could argue about it in code review or something like that. Okay, so I gotta include multiply for that. It also looks like there's probably like a missing implementation of add for that. Possibly. Yeah, I don't know. Well, let's try it out. Yeah, okay, it's complaining about add too, so. So we'll add that in. I would claim that it's probably in the spirit of Rust to not do clever hacks to reuse code. I mean, again, it's like some duplicated effort here, but if you're convinced that colors and vectors are different things, then maybe you want to keep them separate. Okay, so now it's complaining about what is it complaining about? Well, it's complaining about my vec3 here. That's supposed to be color. The other thing it's complaining about is the lack of unit vector. That's still complaining about the vec3 up here. Yeah, unit vector. And complaining about add. What do you want to do about the unit vector thing? Okay, so there's this operation to make a unit vector that it is complaining about. I guess one decision we would have to make about that is how do we want that to work exactly? Okay, so let's go back to the vec code for a second here. Okay, so here's the vector code. There is an operation in here, unit vector, somewhere. Okay, unit vector. I guess the one question is, where does that logically go in the context of this Rust code? Is it just like a free-floating function? Is it should we make it a method of vec3? I mean, I don't know. should wait, where does that thing go? Looks like we're gonna need some code to actually deal with that. So looks like we need like a length calculation to implement that. So it looks like there's like a length squared calculation. Always good to make sure the math works out. Okay, so we need that. And then, I guess the question is just where does the unit vector thing go? I guess we could make it a method here. Could try that. I don't know. Let's just try it for now. I'm gonna put it on vec3, so it's gonna be a method of vec3. So we could do that. It is complaining about a few little details. It turns out that the division operator wants ownership of the self. Okay, so it's a little, there's a little bit of a mismatch going on between this and that with respect to that argument. So we need to fix that. There's two ways we could fix that, by the way. I mean, we could fix it by changing self up here to just be self. The other way we could fix it is to put star there. Okay, so we want to fix that. And then the other thing, I guess I got a little typo up here. The other thing that it's asking me to do is, what do you want? What is the unit vector? It looks like since I made this a method of direction, I guess I can call it like that. Again, Rust trying to help me out a little bit here with the compiler error messages. Yeah, okay. Let's see if it works. Okay, well, it compiled. I guess that is one thing. Does it actually produce the image? Let's go look at what it's supposed to do. Okay, so it's supposed to produce this big blue gradient here. Let's see if it actually does that. Keep my fingers crossed. Oh, okay. Okay, that looks fairly promising. A lot of work to get to that. Kind of a messy thing. The one thing I don't really, like right now is I don't know whether I like this little fiddly thing with the star. I just don't like the way it looks. I don't know. Maybe I'm superficial. Maybe I come from too much Python programming or something like that. I'm going to try changing the self to just a regular self and just see if it works. See if it compiles. Okay. Well, that looks okay. Some people might look at that and say, wait a minute, what just happened there? What is going to happen with that is this value there is going to be owned. Okay, so it's an owned value. Part of the reason why I changed that is a lot of the other kind of operations in the class were doing the same thing. You know, they're using the self like that. So I'm trying to follow the same style. Maybe we could do it for length and length squared up here, except that, yeah, I don't know. I didn't need to do any like fiddly detail in those to make it work. Yeah, leave it for now. Part of the reason that Rust is letting me get away with that is because of the copy trait. I have a feeling some people could be looking at that and just saying, "Oh, the performance of that is going to be crap because now you're just making copies of things." And that's, it's like, I don't know. Let's leave it and leave it at that and see what happens. So okay, so that gets us to the end of section 4. I'm going to pause for a second, take another break, and we'll come back, add spheres. Okay, we're going to continue with section 5. We're going to add sphere to the code. A lot of math. Not going to go through that unless you want me to, but I'm not. A lot of mathematical calculations here, but the gist of what we're going to do is we're going to introduce some code for hitting a sphere, and we're going to try to get this image with the red ball in there. So this is going to be a lot of math calculations. Might have to do some more vector stuff. So I don't know. We'll see what happens. Kind of filling in the vector class as we go. One thing about about converting from the C++ code that I want to mention is that you'll find in a lot of the C++ code, there's all these fiddly details with like the passing of references and other things. You might be inclined to kind of copy that on the Rust side. Might work. I don't know. I find it kind of interesting to not do that. One of the things that I'm often thinking about with my Rust programming is how can I write the code in a way that actually looks nice. And by looking nice, I don't necessarily want to have like just a ton of like weird fiddly details like that. Like maybe this is like a Python bias or something like that, but it's like, I just want to have center, radius, and ray. I don't want to be fooling around with whether it's a C++ reference or something like that. So I'm going to keep it at a high level to start with. Again, partly, I figure like we can always optimize it later or fix it later, but I want to keep the code I want to keep it real readable. That's kind of like one of my criteria on this. Okay, well, looks like we've got a dot product in here. This is definitely something that we're going to have to implement on in the vector code. So we'll have to come back to that. And quadratic formula stuff. This is bringing back flashbacks of my the D that I got in algebra in high school. Okay. Okay, so we're gonna start with that. I know right away it's going to complain about the dot product thing. We definitely did not implement that. So if I try to build that, no, it's complaining about dot. I guess the decision on dot is how do you want that to be like should this be a method? Should it be something like direction dot our direction? Is that what we want it to look like a method call, or are we going to implement it as like a freestanding function like that? Yeah, I don't know whether I have like a super strong opinion about that. one way or the other. Yeah, let's go to vector. Let's implement it as a function. We'll go the other way this time. Okay, so I'm just going to implement it as a function. Function dot. I don't remember the arguments that they passed in the C++ code. But if we were to write it as a function, I mean, it would look something like this. And then I'm pretty sure that's the dot product, if I remember my math class correctly. Okay, so we could implement dot as a free, free floating function like that. I'm following kind of the same convention that the other math operations followed, by the way, in terms of how they handled types. Like they took vec3 in, and so that's taking back. I'm gonna follow that same convention, just to be consistent in the code. So let's put dot there. If I'm gonna use that in main, I probably need to include. Okay, that's slightly annoying, perhaps, but okay, let's include that. Discriminate. Okay, just got a typo on that. Okay, so we got the hit sphere. Now I guess the question is, okay, now I need some code to use that, I guess. Yeah, never used. Okay. Again, Rust is super picky about the types here. If I pass in integers for that, it is very unhappy. Okay, let's try that. Oh. We could do it. You can use return if you want. So I'll just copy the C++ code there. And now we're getting now we're getting a complaint about the ownership of the value here. Okay, all right. Okay, so what is happening here? Is that basically owns the value. This basically owns the value, and this is moving the thing up there. Okay, so that's a move. I guess I have to just, and then the problem is that the ray is being reused down here. Okay, so it's like the R is being used again. So to fix this, I'm kind of back to one of the core things in Rust. It's like, okay, the objects want to move around. How do I want to fix this? I mean, one way to fix it would be to put clone on ray. I could do that. Maybe I don't want to do that. So another way to fix it perhaps would be to make this make that a borrow. Could do that. The problem with doing that is that now I'm going to have to put like a ampersand on that code. That's one way to kind of deal with that. We could argue about whether we want to do that. We could argue whether we want to take this all the way. I mean, should we take this all the way out? Like, should the ray be borrowed the whole way out? Like here, do we do we create a ray all the way out in like the top loop like that, and then just give it to ray color and just say, okay, you're borrowing this? I mean, we could do that. Okay, so that works. One of my general concerns just in the project, and I've mentioned it before, is I definitely want to write the code with all this mathematics in it. I don't want the code to get mixed up with a whole bunch of Rust details, like borrows and stars and things like that. So one concern is just, how can I write the code really, really cleanly? It might be a matter of just like, where do you introduce kind of the extra syntax? Maybe I'm fine with it being out at the outer loop like this, as long as the other code kind of remains fairly clean about it. So let's stick with that for now. Looks like that compiles, by the way. Yeah, let's see what it produces. Yeah, okay, that looks good. Got an image of a red spear. Okay, so got through section 6. Now it looks like we're gonna be, well, I don't know. It looks like a number of things coming up. Okay, it looks like we're gonna be doing a little bit of shading, maybe. I don't know, computing some normal vectors and some other stuff. Again, you can read the math on your own. So it looks like we are introducing just a slight change to the hit sphere. Okay, so let's do that. B. Get our mathematical grouping set up here. Square root is a method in Rust, so that's going to look a little different. Okay, so making a slight change there, and then looks like we're introducing some extra code here. Hit spear. Okay, looks like we have our unit vector thing going on here. So this looks like mostly straightforward translation of some math calculation. Not sure that. Yeah, I'm not sure if that's going to require more operations on vec or not, but let's see what happens with it. Vec 3, vec at t. What is it complaining about? Oh, we changed the type of hit sphere. I didn't notice that. Okay, so there's like a new type coming back from that. Okay, let's try it now. Now we get nothing. That's not good. Got to check all. Oh, okay. Minus. Yeah, this is the danger of typing this stuff in. Is you might miss like a minus sign or something. It can be hell to debug that. like if you're missing a minus sign or some other. Oh, okay. Well, that looks a little bit better. Okay, crisis averted on that. Okay, so we get that. Looks like. Let's see what's going on here. It looks like is this a mathematical simplification going on? Yes. Okay. So this looks purely like mathematical simplification, but let's go ahead and do it anyway. Must be some reason for doing it. So maybe it's performance reason or something. Just gonna comment out that code so I can remember what it was. Okay, well, let's try that. Yeah, it just looks like fewer mathematical operations on that. Okay, so that looks like it's producing the same image as before. I'm gonna delete that. Delete the old code out of that. All right, so we've got this. Got it producing kind of the nice image down there. 6.3 is going to introduce some new challenges. Probably the word to be scared of here is the word abstraction. Anytime that gets mentioned, you should just all of a sudden start running away in a kind of a horror of some kind, because you know that things are going to get bad. Basically, what's going on here is that the project is introducing the idea that there could be different kinds of objects in a scene. Okay, so we're going to eventually build up a scene, and a scene potentially could have many different things. It could have spheres, it could have cubes, it could have triangle, like meshes and other things like that. And we want to have some way of sort of extending the system with different kinds of objects. Okay, and the abstraction that is being introduced is this idea that you can have some sort of hittable thing, right? It's like, okay, there's something that can be hit with a light ray. And so what's happening is there is some kind of class, okay, class here, hittable, okay, so something that can be hit, and then there is some way of communicating data about the hit. Okay, so this is essentially some, like a result of being hit. Okay, so you have that. So there's this hit record thing that indicates what it means to be hit. And then what we're going to do is we're going to create objects that basically inherit from this hittable thing. Okay, so this is some kind of inheritance in C++, and then the logic for the hit is basically implemented there. Okay, so this is the abstraction that is being introduced, and I guess before we get into this, there's a bunch of horrible things that we are going to have to deal with in porting this code. One of the things that we're going to have to deal with is that Rust does not have inheritance. So this whole thing here, that is not going to happen. We are not going to be implementing some sphere class that inherits from some hittable class, because Rust doesn't even have that. The other thing that is a little, well, frankly, a little funky about this whole thing concerns the hit record up here. So this is basically the result. Okay, so this is the result of being hit, except that we don't actually know if an object is going to be hit. What's going to happen is you're going to, like, this ray tracer, it's going to project some ray into the scene. It might hit something. It might not hit anything, and we just don't know. Okay, so the way that the code has been formulated is that a bool is basically being returned to indicate whether it got hit or not. Okay, so this bool basically being returned there. If it is hit, then the result is coming back through like a mutable argument. Okay, so the result is essentially coming back through that. And what the code is essentially doing is mutating that value. I don't know whether it is showing it on the, maybe on the screen. Yeah, okay, well, here it is down. Okay, I apologize for not having that lined up right. But this is where the result is coming back here. So what happens is you pass in this mutable record, and then you mutate to get the answer back. All of this, frankly, is just horrible on the Rust side. The fact that Rust does not have inheritance is one thing. The other thing is that Rust is extremely picky about mutation. In fact, like that's probably a whole like video on its own. But mutation is certainly something that is maybe not. Well, it's something you would probably try to avoid in Rust, and this idiom of taking in an input, like taking in an argument and then mutating it to return a result. That doesn't seem very Rusty to me. Okay, like that seems pretty weird. That's what's going on there. So what we're going to have to do in this section is take a slightly different angle on this, and I'll kind of talk through it as we work on it. But what we're gonna do is we're gonna make a file hittable. Okay, so we're gonna follow the C++ code a little bit anyway. So we're gonna make a hittable thing here. I'm gonna make a structure for the hit record. Rust wants the structures to be camel case, like that, so I'm going to name it slightly different. And in here we're going to have the same fields as what are shown. Okay, so I'm gonna make that. I do need to include some names. Let's bring point3 and vec3 into the fold here, so I can use those. Probably want to implement like a new method of some sort on here. Just kind of following the same convention as what we had before. Okay, so I'm gonna create that. Now, the question is what to do with this hittable thing. Mention of Rust does not have inheritance on this. What we can do instead is implement a trait for this. So I'm going to implement a trait, and the trait is essentially going to define an operation. Okay, so we're going to have like some hit method on here. Okay, so maybe we have a self like that, and basically what the hit method looks like it's taking as input. Okay, so it's going to have some kind of ray coming in. because of that, we had an earlier discussion about ray being borrowed in some of the other code. Like here, it was borrowed. And up here, it was borrowed. I'm going to borrow it here just because I'm kind of, I'm going to follow the same convention as earlier. Okay, so ray is coming in. It looks like we've got ray tmin coming in, ray tmax coming in. And then we have this weird, like, mutable hit record bool thing coming in. I don't want to do that in Rust. What I think, like, probably a more idiomatic way to structure this in Rust is to return an option type. And we'll do some examples of this in a second. But the way to read this is that this trait of being hittable means that you're going to take array along with some, min and max values, and then you're going to return back whether you hit something or not. The option just means the not. Like, maybe you hit something, maybe you didn't hit something. And then if you did hit something, I'm going to return this hit record with some information about what you hit. Like what point, what's the normal vector, what's the t, and so forth. So this is deviating a little bit from the book, from the project, but I'm going to start with that. First thing I'm going to do is add it to the list of modules up here. And I'm going to make sure that the project builds with that. Okay, it's complaining about ray not being in scope. So I'm going to fix the name errors on that. Okay, at least it compiled. Actually, getting a compiler error at least tells me that it's part of my project at this point. Okay, so we're gonna do that, and then what's going on in the next part is it looks like a sphere class is being implemented. Okay, so we're gonna make another file, sphere, and there's gonna be some kind of sphere object being implemented here. The sphere object looks like it has a center point. Maybe I'll make that public as well. Actually, I kind of want these should probably be public as well. Why not? We're all friends here. Okay, so so this is going to be a 0.3. And the radius is going to be an F64. In order to use the 0.3, I've got to use the vec3 thing. Let's just start with 0.3. I'm only going to try to use what I need here. Okay, so we have a sphere there, and we want to probably give it a new method. So we'll start with that. Again, let's go back to main. Just gonna add it to the project. Make sure that everything compiles. Okay, so we're there. Okay, so it does see sphere. It's just complaining that it's never used anywhere. Okay. Okay, so we're gonna do that. Now, how we're gonna integrate it with this hittable thing. Okay, I mentioned that Rust does not have inheritance. What we're gonna do instead is we're gonna implement a trait. We're gonna come in here and we're gonna say we are implementing hittable for sphere. First of all, that hittable thing has to be visible. Okay, so I'm gonna include that up there. Okay, so we're gonna include that. And then I need to implement that hit method that was on there. Okay, so we're gonna hit. What was the signature of hit? It was this. Okay, so I need to implement that for the function. So a lot of the code actually looks it looks pretty similar to what we had before. Maybe I could just copy that out. Okay, so we're gonna have the like this code. Okay, so I'm just copying from what we had before. Okay, so we're up there. Now where it starts to get different is in this little piece of code. Okay, so if the discriminator is less than 0, this returns false to indicate not hit. What we're going to do for that is return none. That's part of the option type up here. Okay, so if the thing didn't hit, we're returning none. Okay, if it did hit, then it looks like there's a whole series of calculations coming back here. Okay, so let's kind of work on this a little bit. Bit of typing here. Rust really hates extra parentheses around comparisons and stuff like that. So if you're used like this, if I put those there, I'll get a compiler warning telling me to take them away. So if you come from C++, you get used to that. This little calculation here where I'm reassigning root to like a new value, you can do that in Rust, but you have to make root mutable. Otherwise it's gonna hate that. Looks like this is kind of doing some kind of clipping or something like that. Now here it's returning false again, so I'm going to return none for that. Okay, so it looks like that was, I don't know, like some kind of clipping operation or some other thing. And then what's going on here is that it is making the hit record. Now, one of the things that's a little strange about this is that there is some, I don't know, there's some kind of cross references, or there's some, like, I don't know whether you want to call it like forward references or back references or something like that being set up. I'm not gonna do that. What I'm gonna do instead is I'm gonna basically make the pieces just on their own. Okay, so I'm gonna actually I need to let t be that. We'll let p be that. We'll let normal be equal to p minus center divided by radius. So I'm gonna make all the values just kind of up front like that. And then instead of returning true, I'm gonna return some hit record. Okay, so that's my implementation of hit. Just as an aside, I feel like this is way sort of cleaner on the Rust side as far as expressing the intent of this method. It's essentially you're sending an array in. It's either going to hit something or it's not, in which case the none comes back if it's not. And then if it does hit something, you're going to return a hit record back, and none of this code involves any kind of screwy thing with mutating argument. Okay, so it's like I'm not doing the C++ thing, but I'm trying to express kind of the same idea there. Okay, so let's put that in the code. Let's see if it actually compiles. Hit record. I need hit record. Like name record. Name reference here. And south radius. Where is that coming from? Let's see. Oh yeah, okay. Like C++ has the you can reference the attributes without putting a self on there, so I kind of messed that up. Let's see if there's any other place. Yeah, okay. I need to put it down here. And discriminate. Let's see. Do I have a typo somewhere? I do. Oh, yeah, okay. And I need dot. Okay. I'm sort of second guessing my use of the dot, or defining the dot as a separate function. There's part of me that kind of wonders whether that should go in the, like on the object there. And hittable new, let's see. Some hit record. Oh, then what is T? Let's go to hittable for a second here. Oh, okay. I put the arguments in the wrong order, at least for the way that I constructed it. If we're gonna do that, then at least I'll make it consistent order there. Okay, Ray is not in sphere. And I'm missing a comma. Okay, so at least got it to compile. Now we're not actually using any of this code anywhere yet, so we're gotta keep going here. Front face versus back face. Okay, so more math. Let's see what's going on here. Oh, okay, so it looks like, let's see what's happening here. Okay, so looks like there is a some kind of method to set something in the hit record. And it looks like this is set somewhere. Well, this is, yeah, okay. I don't know whether I like this. Okay, looks like that. Okay, this is pretty weird actually. What you've got is you have some method on the hit record which sets the normal and then like mutates the value. I guess we could code that. I mean, stylistically, this is sort of a really, I don't know. This is pretty weird what's going on with that. Okay, so there's a new attribute, front face, that gets added in. Maybe what I want to do with this, you know what, let's set it to some kind of, I don't know, some kind of true value on that. And then we're going to have something set face normal. Yeah, I'm not super happy with this with the way that this is the way that this is structured here. Okay, so we're going to take an outward normal vector in here. So we're going to do. We also need a self. You know, we actually need a mutable self on ourselves. So because we're mutating ourselves. So we're going to basically do set front bay is equal to dot our direction outward normal less than 0. Interesting. Okay. And then the normal, I guess the normal vector is being flipped. Like the sign flips if it's facing the other way. I think what I'm gonna do is kind of formulate this in a slightly different way. Not totally happy about this, but okay. So the way that this is gonna work is, I'm gonna just set up. I'll create the hit record, assuming that it's front facing, and then what I'll have is this set base normal thing to basically fix it. Okay, let's so this is going to be the formulation of this thing. So I'll create the. What I'm going to do here is I'll create the hit rack with those 3 values on it. And then I will compute this like outward normal thing. We'll call this rec. This is a little tricky. This is just, I don't know, this is a little tricky just because of the, oh wait, that's, oh, well, the outward, okay, I already calculated I actually already calculated the normal, so maybe this is, okay, so now, okay, so what I'm going to do here is I'm going to set base normal. R. And rect normal. Like that. And then I will return that back. Part of my confusion with this whole thing is it's very unusual to like mutate something like that, like mutate in place. And this is like a really weird kind of formulation of that. I mean, this might require a little bit of study, but basically this thing here, the outward normal, is that, and then I create the hit record with that. And then when I do the face normal thing here, it looks like I have the normal. Actually, I could probably just not pass that as an argument in, because I already created the hit record with the normal things. So let me go back to the set. Maybe I don't need that extra thing passed in there. So instead, what I would just do is look at the normal that I've already got and try that. Wow. Okay. I'm either digging like a gigantic hole for myself, or I don't know. We'll see here. Let's see if it see if it compile. Okay. Oh, okay, we're back to the vec3 structure. It's complaining that I need to implement negate. Can't apply operator minus. It's complaining about some other stuff too. Okay, so let's go to vec3. I'm gonna come in here and it wants me to implement negate for vec3. I'm gonna guess that probably just returns a vec3 back. I don't know. You can always just, try it. So okay, so let's implement negate. The other thing it was complaining about was, it might have been missing like a field. That was in the hittable thing. Okay. And dot. Okay, yeah, okay, yeah. That back to the dot. Maybe I do want to make that a method on vec. So, okay, need ops neg. And okay, it wants the output thing. Again, the compiler is teaching me what it wants, so public trait. Oh, okay. Don't think it wants the generic on that. Okay, so it is compiling, but the question is, do I have any way to test it? Do they provide any tests? Not really. Interesting. Well, they do have something a little bit later with the sphere. I'm sort of debating whether I want to try to hack that or just kind of forge forward here. So essentially, where we're at right now is we have a sphere. There's a hit method on it. It does compile. I don't know whether there's any math errors in it or not, but the next step of the project is basically to create a list of hittable objects. Why don't we just go for it? I mean, I don't know. We'll live dangerously here. It's like, okay, we're doing a lot of code without a lot of testing, and it's I don't know. Cross our fingers and hope that it works. Okay, so the general idea of this 6.5 is that we want to have some way to basically build up a scene, like some scene of hittable objects or something like that. Okay, so eventually, like, we want to have multiple spheres and other things in the scene. Let me see if I can pull up a picture of that. Yeah, like there. Okay, so like it takes a while to get to that, but eventually there's going to be these scenes of multiple objects. So the hittable list is essentially the structure that is going to do that. And it turns, this is going to be a little bit tricky to code in Rust. Okay, so let's kind of look at what we've got here. Okay, so we've got this hittable list object. Hittable list. Okay, so we're gonna start off by kind of following the C++ convention. Okay, so we're gonna have some file hittable list Rust. and I'm seeing inheritance in here in the C++ code. Okay, so I see that. So what we're going to have in here is we're going to have some kind of hittable list structure. Let's see what's inside of it. It looks like, okay, what we got inside is some, okay, vector or shared pointer hittable objects. Okay, let's call it objects vec of something. Okay, so we're gonna have like a vector of some kind of thing. I have some methods to kind of implement. There's some operations on the hittable list. So it looks like there's an add method. That's going to take in some kind of object. That's supposed to be hittable. Okay, I'll do a to-do on that. It looks like there's a clear method, but why would I clear the scene? I guess I'll leave that one off. And then okay, so I'm gonna have so I have to have some way to add to the hittable list, and then the other thing that needs to be happening here is we have to implement hittable for hittable list. This is the whole trait thing. Okay, so I have to implement hit. This is the same interface as before. Looks like we're gonna need I'm gonna need the ray on here. I need hit record, and I need hittable. Okay, so I'm just right now I'm just trying to get the pieces of what I need to get this thing to compile. I'm not quite sure what to put for that right now, and I don't know what's going to go on with the add here. Okay, so this is the trouble with this add is this basically needs to add any hittable object to the list. Okay, so what I need to do in here eventually is I need to basically take like that objects thing and like push it on there. I'm actually kind of copying this. I mean, the C++ code does the same thing. Okay, so you take in like some hittable object and you put it on the list there. Not clear. Okay, so this is maybe not like a bad starting point on this. I know that this is probably not going to compile, but maybe this is like some wishful thinking, right? It's like, okay, I want to add like some object to the list of objects. I mean, maybe we could even just wishfully think this thing through up here, where it's like, okay, there's going to be some vector of hittable object. Maybe I'll make a note that this is like wishful thinking on my part. Okay, so I'm hoping that will work. I also need to have like a new method on here. So this is going to be basically like a hittable list, and then the objects will be, I don't know, some new vector. Okay. So I feel like we're kind of, I don't know, kind of coding dangerously here. I mean, okay, there is a fair amount of kind of wishful thinking going on. Okay, so what I want basically is I want to have a list where there's a whole bunch of hittable objects in there. I want to have some way to add some arbitrary hittable object to the list. And then we're going to have to implement this hit operation for the list. Okay, so this is a to do right now. I think the first challenge on this is just even getting the thing to compile at all. When I build this, so here's my concern with this. Rust does not have inheritance. Like, does not have the inheritance feature of C++. So I have a lot of questions about this, like this hittable thing. Like that was defined as a trait in that other file. Trait hittable. It's not clear to me that that's something that is that at some. This may not be usable just by itself like that. Okay, so let's see what happens if I try to build it. Did I actually save? Did that actually compile? Hittable is, wow, interesting. Okay, well, all right, okay. So that compiled. I guess the question is let's start filling in some details about that. Actually, it occurs to me that I did not add this to my project. I did not add it to my project. That's why it compiled, is it never actually went through the compiler. I was actually thinking, like, why did that compile? Okay, so okay, let's add it to the project here. It's kind of like unit tests. It is one of the advice on unit tests. Like, you should always make the test fail, so that you know the test is actually working first. Then you make it pass. Okay, so let's try compiling it here. Okay. All right. So what is going on here is it is complaining about the trait and suggesting that we have that we put impl hittable there. Now, we actually saw something like this once before, actually, in the color code. This is way back, like a couple hours ago, in the color code, where you had this write color function, where we had this use of the impl there, and essentially what the problem was there is that we wanted to be able to write to any object that supported write. It could be file, but it could be any other thing. That is kind of what is going on in our code right now. What we want to be able to do is add any hittable object. So one way to specify that would be something like this. They would say, okay, this add function, I'm going to let you pass in any hittable object. Still haven't done the to do yet. Okay, so we're gonna do that. So let's try to compile that. So if I do that, it's no longer complaining about the object. Okay, so it's like I don't get error messages about that, but it is complaining about the definition of this vec up here. And it is suggesting that I use the specified dyn on there. I'll talk more about what that means in a second, but it wants me to put dyn on there. To fix that. Actually, a reasonable question to ask here is, why can't I just put impl on there? Okay, forget about the dyn thing. Like, okay, so like this impl thing, it basically says, give me any object that implements this hittable thing. and then I'll put it on the list. And it's like, why? Like, and then object, it's like, okay, give me any implementation of hittable. Like, I'll have a vector of just hittable things. I'm essentially looking for a kind of a symmetry between these two. Like, why wouldn't they be the same? I think that's like a totally reasonable question to ask. If I try that out, I think Rust just rejects it outright. It just says infiltrate is not allowed in field types. It's like, wow, okay, that's kind of harsh. Okay, and it even says that that the infiltrate is only allowed in like arguments and return types of functions. Okay, so specifying that impl thing hates that. Okay, so I'm gonna take that away. Okay, so let me take that off of there. I think what it suggested earlier is to put dine there. Like dine. Okay, so like, okay, actually let me take off the dine and just verify like what it said there. Okay, so if I take that off, it essentially says, oh, you should put dine there. Okay, so we'll okay, let's do that and see what happens here. I'm not actually trying to do anything yet. Keep in mind, I have code commented out. I'm just trying to get the thing to compile it all. If I put dine there, I get a different error that basically doesn't know about the size of this thing. So what is happening here is extremely subtle, okay, and frankly kind of deep. But what is going on with this vector is that this is basically trying to create like an array in memory. Okay, so think about this as memory. You have memory, and you have a bunch of objects that are being created here. Okay, this is your vector, and each one of these objects is some kind of hittable thing. Okay, so you have a whole bunch of hittable things. The issue is we don't know what those hittable things are. They could be spheres, they could be boxes, they could be a hittable list or something like that. But we essentially don't know what it is. Okay? And it turns out that the dine actually is a way of specifying that. Essentially what the dine is telling Rust that this is some kind of dynamically determined thing at runtime. Like, we don't know in advance what is going to be added to this hittable list. And so the dine basically just says this is dynamic. Okay, so at runtime something's going to be added here. So we have this vector of hittable things. We don't know what they are, and the problem is we don't know how big they are. Like, data structures have different fields of storage. Like a sphere might have different fields than a box or something like that. So this error message is basically saying that Rust does not know how big to make like the slot there. Okay, so all the vector elements go into some spot, and it is supposed to be some kind of size associated with that, where it's like, I'm allocating 64 bytes, or I'm allocating 32 bytes, or something like. We just don't know what it is. Okay, so Rust doesn't know what it is, and it is complaining about that. Now, the question is, does it suggest any kind of fix for it? I mean, it's a pretty complicated error message here. Doesn't know about the size of that. Yeah, it's getting all these error messages about memory allocators and other things. Yeah, I don't know whether it suggests much of a fix. Okay, so like heads are exploding, and you're kind of wondering what to do here. So the thing that I'm gonna do to fix this, I'm gonna introduce a new data type from Rust, which is the concept of a box. So what I'm gonna do is I'm gonna make a vec of boxed hitables. I'm like, box? What the hell is that? Let me put it in and see if, okay, so if I do that, it compiles all of a sudden. Okay, so I don't get any compiler error messages, but what in the world is going on with this? Okay, so what is going on with this is that, first of all, box is essentially a memory pointer. It's actually a pointer to some memory in the program known as the heap. If you've ever used malloc or something in a C program, or new in C++, ends up going there. Okay, so box, it's a funny name for a pointer, a memory pointer. Because it's a pointer, what's going to happen is all of the elements of this vector are going to be memory addresses. Okay, so everything is going to be an address, and addresses all have the same size. So part of what's going on here is that this memory address might end up being something like a 64-bit memory pointer, pointing to something else. So I realize my picture is getting kind of messy here, but what's happening is you're going to have a whole bunch of pointers that are pointing to some kind of hitable. Which we don't know what it is. Okay, we don't know the size of the hittable. We don't know what kind of object it is, but at least from the standpoint of this vector, the vector is uniform. It's like coming from C or C++, this is basically an array of pointers that is being created here. Okay, so box is a memory pointer to the heap. The other thing that is going on with box is it means ownership, or it implies ownership. So what this specification is saying is that this object it's not only a list of these hittable objects, but the hittable list is actually going to own those objects. Meaning that they're going to get destroyed when the hittable list gets destroyed. Okay, so essentially you're giving responsibility to hittable list for those objects. Okay, so you give an object to the list is going to own the object. Okay, so that is the first thing about this, is that just to get this to compile, I have to structure this in a very specific way. I have to say, okay, this vector is containing a whole bunch of hittable objects. They are dynamically determined at runtime. I don't know what they are. The box means I'm going to own it, and I'm going to store a reference or a memory reference to that. Okay, so I'm going to do that. That gets it to compile. I don't know. Hopefully, still with me on that. The second part of this thing actually concerns the putting things into that list. Okay, so I have this add method where you give me a hittable, and then I want to put it on the list. Okay, so let's try adding that. I'm sort of debating whether to take all my handwriting away here. Okay, so again, this is going to be more wishful thinking. Okay, let's try building that. All right, it's still complaining about that. Yeah, okay, well, what it's complaining about here is that this box thing is sort of new. What it's complaining about is that you give me this hittable object, you need to put it in the box. That's what it's complaining about. So I don't know. Let's follow the suggestion. Okay, so all I'm doing here is kind of a movement thing where it's like, okay, you give me this hittable object. What I'm going to do is I'm going to put it in a box, which means I own it, and then I'm going to put it on the list. Did I save that? Let's see if it still works here. I don't know, implementation of hittable may not live long enough. That's not good. Box new must be. Okay, Rust is asking. It's basically telling me to put a lifetime on this thing. What is that about? Oh, I know what this is. Okay, yeah. Do we want to go there right now? Let's do what it suggests, and this might require another discussion at a later point here. What did it want me to do? It wanted me to put static on there. Well, let's follow the suggestion and see if it. Okay, it does. It does compile. But I'm just going to leave it at like make a note about the static. But what the hell is that? Okay, like what the fuck is that? Okay, so we'll come back to that. But right now we're just trying to. We're trying to structure this thing where it's like, okay, I got the spheres, I've got this hittable list thing. I've had to structure this in a very specific way, and then there was this static lifetime thing got added on there. I promise I will come back and talk about that, but not right this second. And then what we're gonna do is we need to implement hit. Okay, so let's kind of, I don't know, let's kind of go through this thing. Okay, so we have a bool here, sort of saying whether we hit anything. Actually, you know, and then I hit right. I don't know whether I like. Okay, so let's do like we're gonna let rec equal none. Closest equal array t max, and we're going to iterate over a bunch of objects. Do that, and then okay. So what this looks like it's doing is it's going to call the hit method on basically that object. So because we're using option, this is gonna look a little strange, but I'm gonna basically go to the object and do a hit on it. Basically what this is doing is I'm going to call hit, and I'm going to see if it hit anything. If it did, I'm going to assign this record to the return result. Like that. And then we're going to change the closest so far. might want to do this in a different order. We'll let rec be that. And then we'll return rec back. This is some of the changes here are dealing with the option hit record. So we start off basically saying we didn't hit anything, and then we iterate, and then if we did hit something, then we'll kind of record, we'll update the the distance there, and then set the record to be this record coming back. Okay, so let's implement that. Let's see if it compile. Expected pull. Oh, if this should be let some, I think. Okay, so we're still compiling. One of the things that is kind of interesting about this code, maybe you've seen it, maybe you're kind of wondering what is going on here, is that the code is making use of some C++ features with kind of the shared pointer. Okay, so it's doing some pointer sharing stuff. What is going on with that is the C++ code is trying to basically set up some rules about object ownership. This has to do with memory management and other things like that. So what is happening is this stored list of objects is supposed to have a whole bunch of shared pointers, and there's basically some garbage collection and other things going on under the hood of that. In C++, that is managed through reference counting. Okay, so there's some reference counting kind of thing. You might be looking at the Rust code and say, well, why don't we do the same kind of thing? It actually is possible to do this in Rust. No, there's a reference counting thing in Rust, but I'm gonna stick with what I've got. One of the things about Rust is that it has very strict rules about ownership of objects, and in some sense, me using box up here is very similar to the shared pointer here. It's not exactly the same. It's not a shared pointer, but what I am doing is I'm basically asserting ownership of that. And I am managing the code in a way where I have this ownership of that. So, the project has a bunch of discussion about this, is the use of shared variables and so forth. I'm gonna skirt that. I'm gonna try to stick with kind of base Rust here. I'll use box, but I'm not gonna do the shared pointer thing. We may have to come back to that, but I'm just gonna kind of skip that for now. Okay, a couple of other things. There's a file with some constants in it. I'm not gonna do that unless I see them used. Okay, so I haven't seen any code using infinity or pi or degrees to radians or anything like that. So I'm gonna hold off on defining that right now. Instead, what we're gonna do is we are gonna modify main to use some of this hit record stuff and some of the things that we just did. So let's end with that, or at least do that. Okay, so what it looks like what's going on in main is, first of all, we're going to get rid of the whole hit sphere thing. So it looks like that's going away. What it looks like for ray color is that we're going to take in a hittable. Okay, so there's going to be some kind of world that comes in, which is going to be some kind of thing that implements hittable. So that's going to come in. And then what we're doing in here is we are going to basically just call hit on it. Oh, there's infinity going on there. I think there actually is like a constant already in Rust for doing infinity. Let's just try that. I need to restructure this slightly differently. Okay, so let's, like an extra parenthesis or something going on there. Okay, so we're gonna see if the thing hits, and then if it doesn't, I guess this is this whole background thing. Let me take away the ownership, the little drawing there, and then it looks like what we're doing here is. Yeah, okay, so there's a little bit of code for creating the world here. Okay, so we're going to make a new hittable list. And then we are going to implement some spheres on here. Again, we're not doing the shared pointer stuff, so it looks a little bit more maybe straightforward. Okay, so we're creating the world, and then down here where we do the pixel color instead of. Okay, so here we're gonna pass in the world basically. I think that needs to be a borrow on that. Yeah. Okay, let's see what happens. We'll see if it builds. Okay, using create speed. Yeah, okay. Need to include some names here. Include that. What else are we missing? Oh, we're missing hittable list too. And I'm missing hittable. So. Missing color. Oh, I gotta. Okay, just missing. What am I missing here? Color new. Oh, okay. So well, actually, let's double check. I got a mixing of of colors and vectors here. Does that make sense to do that? I guess. Okay, we do a color plus. Okay. Hit. Oh, I'm missing a 0 in there too. It's one of the dangers of writing lots and lots and lots of code without testing it first. dot. Yeah, okay, got a little bit of a type thing going on here. That's fixable. It's not pretty, but it's fixable. Let's try that. Okay, it compiles. I guess the question is whether if I run it, am I gonna get that? I don't know whether I'm much of a betting person or not, but let's run it. See what happens here. It'll be a miracle if that shows up, right? But oh, awesome. Okay, a lot of work to get through the abstraction thing. We've been talking a while. Okay, so there's a little bit more in section 6, but let's take a break. I'm going to break for a second or pause for a second. I'll be back. Okay, back to resume on this. I'm going to talk about 2 things in the code that we've just written that you might want to fix. One is actually simple, and the other is extremely subtle and sort of semi-evil. Okay, so one of the things that I might want to fix has to do with this conversion that I had to put in the code. There is basically a mixing of vectors and colors that is taking place here. Frankly, it's a little weird, but I guess I'm kind of glad I did this because it kind of introduces an interesting problem in the code. Okay, so this whole piece of code is here because basically this normal that came back is essentially a vec. And I essentially strictly separated the vector and the color class structs from each other. So that's a little annoying that I had to do this. If I knew that conversion was something that might take place a lot, one of the things that you might do is maybe implement a conversion trait. Okay, so this is my color struct here. If I knew that converting this thing from a vec was a possibility, one of the things that I might do is implement the from trait. You could implement something like this, like, okay, I'm going to implement, from. Okay, so there's going to be some from function here, and then essentially the input to this is going to be the vector, I think, and then the output is going to be the color. Okay, so I might add like something like that. Let's just make sure that it builds. Oh, okay. It's complaining about the name. Need the crate for the vec3 here. So I'm specifying kind of a data conversion like that. Okay, so here is basically a conversion going from vector to color, and then if I wanted to use that in the code, there's a couple ways I could use that. One is I could instead of doing this horrible thing here, I could just say color from rec. That's one thing I could do. Is just do that. From rec dot normal actually. Okay, so. Okay, so that's one possibility. Okay, so you could do like an explicit conversion on it. It's a little bit nicer, maybe, is to do that. Let's just run it, make sure it actually produces the same image. Otherwise, I'm going to be hating life later on. Okay, get the same image. The other thing that you could do with this is instead of doing the color from, I could come in here and just say rec not normal into. I think that will also work. Maybe not. No, actually it can't infer the type on that. Now sometimes you can actually do like a type inference like that and have it convert into the type. I'm going to take my comment back. You don't want to do that here. In certain cases, though, where the type can be figured out, you can do that into, and it will do the same thing. Okay, so let's go back to the front. Okay, my bad there. So that's one change that came up. The other thing that I wanted to talk about, and I'm not sure I really want to talk about it, but I need to mention it because it's sort of evil, is what is going on with that. Okay, so this is a lifetime specifier in Rust, and why is it wanting me to put that there? Okay, so I mean this is extremely subtle what's happening here. So let me kind of piece through this a little bit. Basically, this hittable list is you're going to have this vector of memory addresses. Okay, so this is the box. Okay, so what is happening here is you're going to have this list that is pointing to a whole bunch of hittable objects. Okay, so these are all hittable things. The problem is we don't know anything about those objects. We know nothing about those objects. Okay, so the object here, for all practical purposes, is just some, it's some opaque object, right? It's like, okay, there's some hittable object. We literally know nothing about it. Okay, we can't see inside of it in any way. So we have this problem that's just this opaque object. Coupled with that, there is basically the hittable list object lives for a certain period in the program. I realize we haven't talked much about lifetimes or anything like that in this, in this project. But what happens with hittable list is that you essentially create it. Okay, so you create like hittable list, and then what happens is that gets used for some amount of time. Okay, so it's used, and different objects get added to it, right? Okay, so down here it would get destroyed. Okay, so it basically gets created, it gets destroyed. While it's been created, there are things being added to it. Okay, so we're adding objects to the list. Okay, somewhere in the middle, not object, okay, just object there. So we add the thing, but again, we don't know anything about that object. Like literally nothing about the object. Okay, so this is completely just opaque to the hittable list. Now, here's the problem. It's possible that this object being added to the list. Okay, so let's say you have some object here. Okay, this is my hittable object. It might have some object inside. Okay, some kind of inner object being held in there. And what Rust wants to know is, does that inner object live at least as long as the hittable list does? This is extremely subtle, but basically this object that is being added has to exist for the entire lifetime of the hittable list object. And Rust is like really concerned about this. It's like this hittable list, whatever it needs to do, it needs to outlive hittable. It has to outlive the hittable list. So the use of static here is partly Rust being concerned about that. What the static is basically saying is that the object needs to live for the entire program. Well, maybe it doesn't just like. Okay, so it needs to live for the entire program. that may be a little bit restrictive or maybe a little bit too broad or something like that. But basically, Rust it does not want these hittable objects to outlive the hittable list. That is what's going on here, and the thing that's a little bit subtle about it is that this vector actually owns the object. Okay, so I want to emphasize that these are owned. The fact that they're in a box means that they're owned. So this is like really subtle. It's kind of like this vector does not want to own an object that might have some kind of inner reference to some other object that doesn't live long enough. There'll be a quiz on this later. This would actually be an excellent kind of final exam question for like a class, a college class or something. So there's this kind of this question about the ownership of this. Now, there is a way to fix it, but you kind of have to, okay. So here's how you might fix something like this. What I'm gonna do with this is I am gonna put a lifetime on hittable list. Okay, so this is sort of specifying like how long hittable list is going to live. And then in here, I might have my syntax wrong, by the way, but Rust will let me know in a second. Is I am basically asserting that whatever this is, like the hittable object, has like no components that live less than the hittable list. Okay, so that's part of what is being specified there, is that the objects in the list do not have any components with a shorter lifetime. Maybe I'll just rephrase this. Okay, so it's kind of a weird assertion that's being set up here. It's like a rule in the compiler. I'm basically saying I have this list of hittable objects, and I am guaranteeing that those hittable objects do not have any kind of inner component of any sort that has a shorter lifetime than hittable list. Because otherwise we're going to end up with like a dangling pointer or something like that. So I'm gonna introduce that. And then I have to introduce the lifetime down here. Okay, so I'm gonna have hittable list object. And what I can do in the code is actually change the static to the quote A. Okay, this may be all that is really required on this. I might need the A here. Okay, so I'm introducing a lifetime on that. Let's see if it actually compiles. Maybe do I need? Maybe I don't need that. Let me take that thing off of here. I have a feeling that I do need it somewhere, but I'm just not. Oh, I know where it might need it here. Okay. Let's try that. Okay, now it compiles. Okay, the syntax on Rust kind of baffles me sometimes. So this thing compiles. It should run and produce the same image. Heads are fully kind of exploded on this thing, but I think maybe the way to kind of think about this is that you're going to be creating this world of objects. That's what hittable list is about. Basically, if we go to main, we're creating this world of hittable objects. Okay, so we have this list of hittable objects. What the lifetime is basically specifying is that these objects that I'm putting into the into the world of hittable objects do not contain any kind of references to data that's going to go away while the world is in existence. Okay, so that's one change I might make there. I guess we could have a debate whether this, doing this is any better than the shared pointer thing that the C++ code was doing. Okay, so the C++ code was doing all this shared pointer stuff with reference counts. I'm not doing reference counts, I'm doing lifetimes, but I'm having to make this assertion that the objects I'm putting into the world at least live long enough. If for some reason Rust can detect a violation of this, well, then I'll get a compiler error message. I'm trying to think of an example of where I could violate this. Probably, I may have to come back to that at a later time to do that. But this is like a very specific, kind of relationship that is being structured here. Okay, so that's one change that I might make on the go. So what we're going to do in this kind of last part of section 6, I'm going to leave that behind for now, is there is a little bit of refactoring of code to deal with intervals. I mean, it says they're going to use that fairly often, so that's the final thing that I'm gonna code in this part. Basically, is that, and then we start moving into section 7. So let's do the interval stuff. I don't know whether these need to be public or not, but okay. So I'm going to start with that. Looks like there's a few little kind of methods being defined here. So contains and surrounds. Okay. After the last bit of code, this feels like, I don't know, like relief or something like that. So there are some some constants for like empty and universe. I'm gonna leave those off unless I see them being used somewhere. Big thud above me in the house here. Okay, so let's start with that. I'm going to add interval to the project. Let's make sure it builds. Okay, just missing a self parameter on that. Okay, that looks good. And then looks like, okay, so they're refactoring the hittable interface to use intervals. So this array tmin tmax thing looks like that's going to be just an interval now. And then we're going to have to go through and fix this, all the spheres and hittable list stuff for that. I don't think it's too bad. We just a little bit of renaming on some stuff. Team in. Oh, actually, no. We're just passing in the array thing. I have a feeling I'm probably going to need a clone or something in here, somewhere in the code. Let's bring that in. Just a few little. Oh, actually, they're making more changes here. Let's see. It's always scary doing refactoring stuff. You never know what's going to break. I think I need to include interval up here. And then in main, they're doing something with the interval here. Okay, that looks good. Let's see. I have a feeling that there's going to be some kind of clone or something bad going on with it. So. Oh, let's see closest. So. Oh, okay. I see. Didn't quite do the hittable list right. Okay, so we come back to compiling, and let's see if it produces the right image. If not, then we're in a world of pain. So, okay, back to that. Okay, section 7. We're gonna be doing some things with cameras. It looks like. And then we move into some things with okay, a whole bunch of stuff with cameras. I think this is a good pausing or stopping point for the for the moment. Maybe I'll split this into 2 parts. Okay, so maybe that's going to be the end of part 1, sort of setting up rays, setting up objects, the world, and so forth. We get into part 2. We'll be dealing with some things with cameras and materials and other things. So I'll see you in part 2.